were shown by Shri how to follow us and how to ask questions. And I want to say we promised an interactive webinar, and it will be interactive because you will see how things are really programmed. It won't be just a set of PowerPoint slides. But following from the very successful webinars we had in April with Abu and Azbu, we have started a question and answer page on our website, www.drm.org. And some of you maybe have found their names on our website with their questions and our answers. So please ask your questions. We will answer all of them. We'll try to answer. Some of them are not very easy to answer, and there are no easy answers. But I hope that DRM for Education will excite you and will give you ideas and also other questions. So if we go now to the next slide, I just wanted to share with you just a very few quotes from famous people. I don't think you need to be reminded how important education is and how education people connect, improve themselves, and in the words of Nelson Mandela, change the world. So we are all, I think, convinced that education is an important thing. And of course, the mission of radio, a lot of broadcasters have really taken the cue from the BBC, for which I worked for about 30 years, saying that the role of broadcasting is really to deliver information, education, and entertainment. We will say education first, information, news, and emergency warning, all delivered through DRM. If we go to the next slide, I will just want to, controversially maybe, pick up one issue. A lot of people have talked about delivering education through IP, internet. A lot of effort is being made to provide the laptops. I am now in London, and we've just been told that 1 in 5 children has had no education, and some of it was because they didn't have access to laptops, they didn't have broadband, they didn't know how to start a laptop and learn from a laptop. And I just wanted to remind you with this little presentation that actually IP, important as it is, and I'm not talking it down in any way, is not available to everyone. The world stats show that Asia, for example, has about half of the population have access to IP and laptops. And that is, of course, a median value, because there will be countries like Singapore or Hong Kong or Taiwan or Japan where this figure is much, much higher. But there will be many, many other countries and places in the Asia-Pacific region, on other continents, where the 53.6% is much lower. So what is the conclusion? The conclusion is that you need the internet, definitely. You need the 4G, 5G, broadband, Bluetooth, Wi-Fi. All this is needed to be connected to today's world. But in order to deliver education today, you need to use a platform that exists. And this is about, I don't know, 200 million FM radios, the increasing number of digital radios, the radios in cars. After all, radio, when everything is said and done, is probably the widest used platform. That's why we are trying to show how digital radio can provide a complex solution for education. Because if you think, okay, I'll put some audio on radio and that is your lesson, I can guarantee you that no child would stay next to the radio for more than 5 or 10 minutes. So you need to make it as veridic, as close to a proper lesson, as interactive as you can, so that education is really delivered. So if we go to the next screen, and I hope I have argued this, and I have made a little comparison between internet and radio. I just wanted to remind you very quickly, even to people who have joined us for the first time, that DRM, Digital Radio Mondiale radio technology, which is the only full successor to analog AM and FM, gives universal and free access to information, education, and entertainment to all citizens in the country. No point having 2 laptops in your car. If you go to a village 20 kilometers away, then you have no electricity and nobody has ever seen a laptop. That's no use. It is also useful because this bouquet or this bunch of excellent features which can be used in education can be delivered no matter which bandwidth is used. And remember, digital radio, Mondiale digital radio means use of spectrum more efficiently, reduce costs in energy. And you will see, I think this is the main point, you will see how radio, digital radio, DRM, can become a really media hub. That digital radio can deliver audio, but so much more. And I don't want to reveal how much more. Okay, if we go to the next slide, please. Yeah. Next slide. Oh, just to let you know, it's very interesting that we have got some questions already about receivers. Where are they? Well, they exist, and this is just a quick reminder of the over 2 million receivers in cars in India, how they look, and also the other versions, the standalone receivers and the mobile versions. I won't go here into a big discussion about receivers because we've got questions about where are they high quality, what is the price, why don't they penetrate a bit faster in certain countries like India, and why don't the people in the forecourts where the cars are know a bit more about DRM. All these questions are valid, and let me tell you, work is going on all these issues. But as you know, change, and especially change in digital radio, is not as fast as we would like it. It's much easier to put a webinar together than to tell Maruti Suzuki and Mahindra salesman somewhere in a corner of India that DRM has all these advantages, and you get it in your car without paying extra for your receiver. If we go to the next slide, I think I will be able to conclude my little education and invite you just for a brief moment to go with Alex through the major features of DRM so we can get to DRM education. So hang tight, put your seat belts, and we'll continue. Alex.
Great. Good afternoon, everybody. As always, it's an honor and a pleasure to be with all of you and to be hosted by ABU in Aspo. Great. So let's have a look at how digital radio DRM can deliver for educational purposes. First of all, as we probably remember from the last 2 webinars that we did, if you had the opportunity to join, DRM has all the tools in place to be the right delivery mechanism for lessons and education in general. Information available at the fingertips of the listener. It has the audio, the classic radio application. It has now, thanks to digital, the text component where we can deliver full lessons and background information, but also general educational aspects on health issues, latest updates and news, information that people may not have easy access to otherwise. And finally, DRM can be used as a delivery platform. So even once the schools do reopen up, but they may not have easy access to learning material, that's again an aspect that could be shipped through DRM as a file download in essence. But our focus today is on the key features as a quick reminder of DRM, and then how we can make it, turn the DRM platform today into a very powerful distance learning tool for the students that are cut off actual teaching where the schools are closed or people are too remote, and cut off from internet sources to be able for homeschooling. First of all, the reminder, as Roxanne already mentioned, DRM is available for all the broadcast bands, local services, as well as long distance, using the former AM bands, where it combines the benefits of digital radio with the physical benefits of these bands in terms of efficient wide area coverage. And that, of course, is a crucial component for these kinds of distance education applications, where you want to reach people that are outside the big metropolitan hubs with their fantastic mobile networks. The next aspect is the key features. I will just quickly remind you, we don't go into any of the details except for two. First of all, there's more choice on DRM. With every single transmission, there can be up to 3 programs plus multimedia content. And that is the element that we will be focusing on in this hands-on session. Give you an example, give you some inspiration, how you can use DRM today to start your own distance learning platform. It has excellent audio quality, particularly compared with analog AM, where even in the AM bands, you can now deliver stereo FM sound quality. Multimedia applications are a key component of digital radio. That's everything that goes beyond classic audio. It can be file transport, it can be journal line text, and it also includes elements like images that can be transmitted, particularly from local services where the capacity is higher. DRM as a digital radio broadcast standard gives you a great opportunity to reduce significantly the power consumption of your national networks, and at the same time really increase the availability of radio to people thanks to the higher robustness and new approaches to network coverage like SFN single frequency networking. You might remember that term. Just keep in mind there are new ways to build up your networks, more efficient ways to build up your networks in DRM. There are convenience features in DRM. As a listener, in future you will tune to the station name. No longer do you have to remember frequencies or bands. It doesn't matter. You select the station by label and by service logo, and then it's the receiver's task to keep you tuned to that particular station, even if you reach the coverage area and the receiver needs to retune and find an alternative source for that service. And finally, one of the key benefits of digital radio that, for example, is now at the heart of the rollout in Indonesia is emergency warning functionality that DRM provides, where we combine the capability of sending out explicit alarm signals that allow to switch over a receiver to an emergency program or even to switch it on, and then having the emergency program consist of audio plus textual information to serve travelers in different languages, tourists, or even different language groups in a country, to serve hearing impaired people with a textual component, and to provide detailed instructions and information for on-demand lookup that otherwise you could never announce over the air, such as shelter locations and instructions where to find shelters for every region and area in the case of a rolling in tsunami at the shore, as an example. So our focus now is on multimedia applications first. The standardized data applications in DRM that every broadcaster should broadcast and every receiver should receive are the DRM text messages and journal line. DRM text messages is the small scrolling text accompanying an audio program. It typically has the program-related content, such as the currently playing song title, the artist name, the program name, the announcer's name, all of this information. It's updated automatically by the broadcaster, so whenever you glance at the screen, there should be some useful information. Journaline is the interactive text information service. We will have a look at that in a moment. The other components, slideshow, EPG, and traffic information, are more tailored for local services where we have a higher capacity. So the equivalent of digital FM services in future. All in all, these added value components in DRM really provide great listener benefits and show the potential, and also increase or establish a new revenue source for the broadcasters, for commercial broadcasters. In our case, we want to now see in this workshop how to apply the journaline component in particular to the use case of distance learning applications and how you can make use of that. So let's have a look at journaline first. What is it and how does it work? What are the features provided by this particular text application? Like all text applications in DRM, whether it's text messages or service labels or journaline, all of them are based on Unicode. So you can broadcast any script that is covered by Unicode, which is basically all the scripts in the world. Journaline supports all classes of receivers, meaning that it is designed in a way that it can be implemented without effort, even on the smallest, cheapest receiver, with just a 2-line text display, and that's it, in terms of resource requirements and interactivity requirements with the user. It doesn't require a touchscreen. And it can trigger interactivity, the hot button feature of Journaline, where the listeners can interact directly with the broadcaster, and it has a feature of geo-awareness, where every single page of a Journaline service can be linked to a specific location or region. That's a core component that we need, for example, for the emergency warning functionality, where the exact affected area is provided in the Journaline component that's part of the emergency program. Now, digging into the details, a little bit of technical background on the Journaline. Journaline really is designed to enable the efficient and on-demand text information services in digital radio. Keep in mind, this information is broadcast as part of the radio service, so it travels the same distance, it reaches the same people. There's no internet required. It's free-to-air information accessible by everybody who has a DRM radio set with the appropriate feature set. Journaline is specifically designed for digital broadcast with even using very low bit rates. So if you have a very, or if you have a transmission scenario, let's say on shortwave or medium wave, where you rather want to have a robust transmission instead of more programs, that is still supported by Journaline in the sense that it doesn't require much of a bitrate. So your audio quality or the number of audio services that you can transmit is not affected when you add a Journaline component. As a broadcaster, it's important to understand that you can reuse existing data sources. The interfaces are all there in the broadcast head-end systems, content servers that we will see later, RSS feeds and XML data sources, content management system. All of these can be connected automatically to generate your Journaline output on the radio, and therefore you reuse your existing data sources that you create anyway for your programming and for your internet services today, and make those available on the radio sets where people are actually listening to your station. As I mentioned, it is designed to work on even the most inexpensive consumer receivers, but it also supports high-end receivers with graphic screens, touch screens, and beyond that, even automotive receivers with a text-to-speech output option. And finally, there is advanced features that more advanced implementations and receivers may support in Journaline. One is the hot button back channel feature, where with a push of a button, I can connect to web pages, to phone numbers, make SMS, voting, polling people, and all of these features. Geotagging is available to locate every single piece of information, and speech hinting was added to the specification with the help of the big car brands to make sure that this service can even be used in car and driving scenarios. So much about the technical background. From a content perspective, there are two major content elements that can be provided over Journaline. One is general information that is program independent, such as the latest news, sports updates, tables, even in-game live updates of scores. You have financial information, airport departure times, advertisements, of course, if you're a commercial stations, all of this kind of information. In India, Man Ki Baat might be one of the big pieces of information that would be relevant in this category. And distance learning and education services are definitely part of this information category. And then apart from that, there's also the more program-related information. If you broadcast the Journaline service along with an audio service, here you have the station contact information, impress on page for listener feedback, how to reach the broadcaster, and so on. It can give background information on the currently running program, phone links, how to participate in a call-in show, the songs played during the last hour, including a direct link to purchase the songs, captions for captioned radio, which is a mandate in some countries where you have to provide a subtitle your radio service for the hearing impaired. This kind of information is all available and can be done through Journaline. The important message of this page is that Journaline is a platform, and it is up to you as a broadcaster to decide what kind of information is relevant to your listeners and your audience. And our focus today will be on that one application type, distance learning education, to inspire you how to possibly bring up a service like that. If you're a commercial station, there's also benefits in Journaline. You can use it as a measurement tool of audience using the hot button interactivity feature, which gives you relative participation numbers and interactivity numbers during the day, a very immediate and instant feedback. But it is also a good tool for ad placements. In the past, ads were placed on the audio track only, and they are fleeting. In Journaline, you can have the more detailed information. So from your on-air announcement, you could then refer the listener, if they're interested in more information, to the associated Journaline page, right there available on the receiver. But you can do even more. The audio announcements in the past were meant for everybody. Everybody tuned to that station, listened to the same audio announcements. In Journaline, we have an interactive service. So that means by carefully designing the menu structure, you can place ads on pages that are very much tailored to specific audience groups. An example of such a menu structure could be, your first level is the language selection. So when I enter the Journaline service of BBC, it offers me the information in English, in different languages. And I select the language I'm interested in. Then it gives me general information or region-specific information. I select the region and the city that I'm interested in, and then my topic of interest. Do I want to learn about the local sports club and the results, the latest results, or the cinema times, and so on. At that point, I have clearly categorized myself. At that point, it is clear what is my preferred language, the region I'm interested in, the topics I'm interested in. So any ad that you place on that page is much more valuable than an ad that is broadcast equally to everybody. So it's a great potential to combine the benefits of internet ad placement with the benefits of broadcast radio. One of the applications for Journaline that have been shown and presented to the public at DES recently, beginning of the year in Delhi, is the public signage service. Public signage means that we take the Journaline information and present it on public screens in public places to the wider audience. Again, with the idea that people should get access to information, free access to information without the need for internet. And a good example, what kind of information should be presented here could be the stock prices, onion prices, and stuff that is very important for the rural people in India, in some cities and villages, where in the past there was a discrepancy between the richer people having access to this information, being more informed about the current pricing, and then poorer people, just due to lack of access to information, being cut off and overpowered sometimes in terms of what the right price, market price for a certain stock would be. Now, with the public information service, you can provide this. You can provide general news, sports updates, some form of entertainment to the wider public without any limitations through DRM digital radio. And you can also use these terminals and screens once you have put them in public places, of course, for emergency warning functionality in cases of pending crisis. And a quick demo is shown of that in the video that we're now going to play.
DRM, Digital Radio Mondial, is more than just your digital next generation AM and FM. It can do a lot more for the public and for the good of the society. Let's have a look at one example that we are presenting at BES. This is the public signage service based on DRM transmission, which means that this public signage service to be installed in a public place does not require any internet, any working IP, any mobile connection. It receives the information over the air from the DRM transmission of all in the radio. In this case, the content that is presented on this public signage demonstrator is exactly the same journal line content that is shown on all the radios receiving live signal here at the booth at BES. In this case, we have lots of information, sports updates, latest political news, we have celebrity news, mandi prices, the latest stock updates on onions, and so on. Plenty of information sources. However, the true magic happens if, God forbid, an emergency happens. Let's say a tsunami is rolling in, and the public needs to be informed as quickly as possible to get away to find a shelter. This is what we can do with the public signage as well. Actually, in the case of an emergency, the public signage screen becomes a full public announcement service. We switch on the audio, we alert the people surrounding the screen, they have the bar that indicates there's an emergency going on, and we have the information, the news about the type of information and what people need to do to get to safety.
Okay, so much about this. There, to just quickly show you some live content that's actually on air in Journaline, we want to now switch over to the to a monitoring system. Timaya, can you switch over to the browser? Okay, so this is a monitoring service available for the DRM members online, where over time all the DRM transmissions should be included. At the moment, we can have a look at some on the radio stations, for example, or Radio Republik Indonesia. A good example of Journaline content could be, let's start with Radio Republik Indonesia. They just came online recently. Here we have in their DRM FM transmission that's going on, we see three services. One is a pure data service in DRM, only consisting of Journaline, and two are audio services, Pro 2 and Pro 3, consisting of the audio component, of course, the text message information, the scrolling text, and the Journaline component. And if you look at the Journaline component, obviously the rendering will look different on a small screen radio than on a nice graphic screen radio, and it will look different again here. But the content, the text content, is fully accessible. That's the core information. So here we have different news categories available, national news, sports news, whatever, in Vasa. We have, so if I select one of these topics, I can then look at the individual news items that are presented under this information topic, and I can read the detailed text information. It's like an electronic newspaper, basically. And I can then easily cycle through the different articles that are presented. Okay. What we we also have included here, and this is currently on air in Indonesia already, is the latest news from the DRM consortium, including the webinar that you are listening to at the moment. Very good. So you see how the information is spread and the education is increased. And you have contact information as one component of Journaline. In this case, RRI provides the detailed impression page, contact page, the different telephone numbers, email address, web address, and also provides all this information as an interactive push button link directly for people that do have a connected radio, such as a Wi-Fi radio or digital radio built into their mobile phone in future. That's one example. If we go to another example, let's say from All India Radio, the Nangli site shows quite well what is available in terms of content at the moment. You have different types of news already available. These news at the moment are again synergized from news that are prepared from a content management system anyway for the web services of All India Radio, and now we can broadcast them through DRM to all the receiver sets without the need for internet. So it's a reuse of existing content. And there is program information, scheduling, All India Radio information, what's the organization, what's the mission, contact, and all of these elements that we mentioned. Just to quickly prove the point that DRM uses Unicode, there's a good example here in Bangalore, which already has in their Journaline service also local information in the local script, obviously. Okay, you got the point. This is Journaline. Now let's dig into the actual workshop, the hands-on part. And for that, we start with the typical network layout. That's some basic information you need to understand to make sense of what's coming afterwards. The typical distribution mechanism or transmitter, studio transmitter link in an analog world looks like this. You have one audio program that is distributed long distance to each transmitter site. And of course, providing an audio stream is quite a challenge. You need capacity and reliability and all of that. And then it is amplified and modulated by the transmitter and broadcast on air. Same in FM, in the FM band for local services, where in some countries you have even whole regions covered, multiple transmitters. Now, if you wanted to do that in the past with analog FM, you had to assign individual frequencies to each transmitter, because otherwise, in the overlapping areas, you would have a signal destroyed. So quite a waste of frequency use and spectrum use. In DRM, that looks a bit different. Here, the program provider or the studio covers not only the content generation, the different programs and data services, but also the hosting of the DRM content server. That's the digital head end. And you will hear about the content server more in a moment. That's the hand-on part. The DRM content server is responsible for encoding all these audio programs into digital XHE AAC format, to manage all the data services, the different data sources, and to create the Journaline components, the images, all of that, everything you want to broadcast. It also is responsible for creating the on-air configuration. Do you want a more robust signal on the air, or do you put more emphasis on content capacity to put more programs on air? All these configurations can be done here in the content server. The output that is sent out from the studio to each transmitter site is then a simple IP link. And compared with a plain audio link, it is very low bitrate. Plus, it has built-in features such as forward error correction, so it can cope with small glitches or dropouts on the line, other than an audio connection. And finally, one aspect is shown here. I mentioned it earlier, SFN, Single Frequency Network. That's a huge breakthrough capability of digital radio, which allows for new network planning approaches in future, where you could cover a region on on the same frequency with synchronized content, same content. So it's a very efficient way of having multiple transmitters using a single frequency, and therefore being mindful of the scarce frequency resource, the bands that are available. So that's a possibility here. Now we want to start and focus on, with all this background information that you now have, DRM distance learning. How can we configure an actual DRM transmission to be ready as a distance learning service, as a radio education, radio schooling service for your audiences? As I said, this is not, of course, a complete solution. It shows you how it is done in principle, and then it is up to you as a program provider to use this toolbox and get creative with it and fill it with life and the proper service. What we can show you today are the technical basics and the tools available to enable this service. I will share this session now with Timaya. So in a moment you will also hear from Timaya. He will take care of the practical configuration demo. The first part of this configuration and demo will be a quick walkthrough of the DRM content server. We already looked at the transmission chain. Then we will have a look at the multimedia player, the receiving side component, and finally the listener experience that we want to achieve in this hands-on experience as the distance learning demo. And to achieve that, we use the content server. We have to configure service components and multiplexes. Don't worry, we will introduce you to these terms. And then Timaya will also show you how you can easily use the different data sources to feed into the content server to create a journal-line content. And we will end with a live demo, how the service can look like on air, live on air, kind of, for the listener. So let's start with the transmission chain overview. This is now a different view of what you saw earlier. In DRM, we have the data sources and audio sources. They are fed into the content server. And the output of that content server is then distributed as that small bitrate MDI stream over UDP IP network. At the transmitter side, you have the DRM transmitter with the DRM modulator built in that takes this MDI signal as input and creates the output signal, amplifies it, and puts it on the antenna. The content server is typically installed somewhere in a well-protected rack. So to configure our on-air transmission, we have this web interface that allows us to change the on-air configuration, add data components, change the audio quality settings. All of these settings can be changed and also scheduled for your on-air transmission using that content server interface. The interface is remote using any web browser. So this is what we will do in a moment. We will connect to the web interface of a physical content server that actually will reside in Germany, but it doesn't matter. And on the receiving side, there is a similar software tool where the MDI signal that is sent to the transmitter, the same MDI signal can also be decoded and received in a software radio. So that's the same experience that we will get on a regular radio in the field, except that we are bypassing the on-air part. We take the MDI signal, the digital DRM multiplex, and receive it, decode it directly in a software radio. So effectively, in our demo, you will see when we change the content server configuration, how it will affect instantly our receiving side in the DRM multimedia player. Let's get started with a walkthrough tour of the DRM content server. Very briefly. Timaya, can you switch? So as I mentioned, there are two components that we need to look at. The first element responsible for our on-air transmission is called the DRM multiplex configuration. That's the configuration of our on-air signal. As you can see in this example, our configuration that we are broadcasting includes a Jazz World radio stations. It includes the Journaline Pure Data component and some other radio station, Planet Rock X. These stations have the service logos, they have a label, they have the description of what the station is about, as you can see here, and they have text messages, and they have a Journaline demo component. So here you can read about some example content for Journaline. This multiplex configuration was created here on the broadcast side to the left of the screen in the content server. This is the user interface of the content server. On the start page, you see a graphical overview of the system status. At the moment, all the components are green. That's what we want. And if there's any issue, we can then use this graphical overview to dig into the details of what the issue is. We have also a summary status at the top of the screen, always visible. And the actual configuration is done through that main menu, where in the broadcast configuration menu, we have service component editor and DRM multiplex editor. These are the two important ones that we need for our on-air configuration that we will be using today. There's also access to detailed broadcast information, configuring audio interfaces, and online documentation, plenty of other stuff that you can use. In addition, there is an on-air box that is relevant for us. It shows us the current system time and time zone of the content server. And at the moment, we are broadcasting a configuration, an on-air configuration that's called DRM radio. That's the label that we gave it for our internal purposes. So on the right side, this particular configuration, Jazz World, Journaline, Planet Rock X, and the audio configurations associated with it, this is what the content server has stored under DRM radio configuration. Now, if we enter the DRM multiplex editor, here you see that there can be multiple on-air multiplex configurations created at the same time. Each of these boxes that you see here is a full on-air configuration. And actually, the one that has the obvious orange border around it, that's the one that is currently being broadcast on air. So as you can see, our DRM radio configuration, that's the same we have here in the on-air box as currently being live. That consists of 3 services out of the potential 4 in DRM. We have an audio service, Planet Rock X, which is internally composed of an audio stream, audio component, and the source we have named Planet Pop. There's a text message component. These are the text messages that you see here. And there is an EPG component to broadcast the service icons. In the Jazz World, we have the audio and text messages for Jazz World, along with the metadata and signaling information. And we also have now a Journaline component as PAD, Program Associated Data. And as you can see, when the listener tunes to Jazz World in the receiver, the text messages and the Journaline show up automatically as part of that audio service. And finally, we are providing the same Journaline content, so it is only transmitted once, as a standalone data service to the listener. So if you want to look up text information without any link to an audio service, that would be available here as a standalone data service in the same transmission. Keep in mind, once this actual data component called a service component is the same, if it's used multiple times in your transmission, it is actually only transmitted once, so it only occupies capacity once. And that's also shown here. In the channel parameters, this is our on-air configuration of the signal, whether it's more robust or more data optimized. These channel parameters result in a channel capacity available for our audio and text content. At the moment, the channel capacity is 186 kilobits per second. That's what we can transmit using this particular on-air service channel configuration. And this available capacity is now split up, if we hover here over these green bars, over one audio component with text messages called Planet Pop. Then we have another audio service component, Jazz World, with text messages. And here we have a packet mode put on air with our journal line and service icons in a single packet mode stream. So all the service components that we have placed on air at the top, those service components are physically transmitted and require capacity on air. And then we can use those service components and reuse them to create the services that the listener can see and select on the receiver. So that's an important message here. The services that we present to the listener, are pure signaling, and only the service components that make up these services, that are the actual audio and text data that we transmit as this service, they are the ones requiring capacity. Good. Now let's have a look at the details, and unfortunately I already clicked on it. So this is the overview of our on-air multiplex configuration. If I click on the headline or the edit button, I can then start editing this configuration, and I get a warning because this configuration obviously is already on air, and any change will be reflected on air immediately. We have general information about multiplex parameters. A new thing that might be relevant for the participants, for example, in the Arabic states, is here the regional profiles for all the text services, text labels, and text messages, where the receiver profiles are now implemented. So I could switch to the Arab States Broadcasting Union profile or the Indian core profile. That is a pre-selection of scripts that the receiver is expected to support in these particular regions. So on the broadcast side, the content server makes sure that all content we are broadcasting and transmitting actually will adhere to these particular profiles that you have selected for your transmission. And I can signal time zones and stuff like that. So these are overall multiplex parameters. Now the individual DRM services that we present to the listener are defined here. I select the service components that make up our service, audio, text messages, program associated data. And then I can specify and configure sorry, there's always a bit of lag in the operation. So then I can also specify the metadata that is presented and signaled to the receiver. To give you a quick example, the DRM service label is what is being presented on air. If I want to change that from RockX to Planet Pop, I can now say check and save our change. I will get another warning that I'm immediately affecting the on-air signal. That's fine. And now what happens is that the receiver will be receiving a reconfiguration announcement on air, and that's shown here in our on-air box. So the on-air box tells us that we are now sending a reconfiguration from the current DRM configuration to the modified DRM on-air configuration. That takes a few seconds, and after that, our service label, as we can see here on the receiver side, is actually changed from Planet RockX to Planet Pop. So we did that change, and it was instantly provided to the receivers. And the final element in our multiplex configuration, after the DRM services and composing these DRM services, is that we have to define the on-air channel, the actual physical transport. For that, as I mentioned earlier, there are the channel parameters, where I can select the robustness mode, MSC modulation mode, protection levels, and stuff like that. These changes affect the available capacity that we have available for our transmission. So every time I make a change here in these channel parameters, the available capacity for my data, for my actual audio and multimedia data changes. And then I can now decide how to split up and total capacity for each service component that I want to transmit. At the moment, as you can see, at the moment, the audio service component here, pop, and here we have the jazz world. Yeah, this is our audio stream jazz world. It uses 60 kilobits per second. There's always this auto-optimize button. So for example, if I say Planet Pop is not so important, I want to reduce the capacity to 50 kilobits per second, and which means that now we have, 50. Which means that now we have some extra unused capacity in our multiplex, which of course is something you never want to have, because that's wasting on-air capacity. And we want to use all this available capacity for our Jazz World service. Then I just click on the auto-optimize, and it will select all available capacity and the best possible parameter set for our station. That's how easy you configure your on-air transmissions. There's nothing else to do. I say check and save, and the new configuration will be on air in a few seconds. Good. This is how you configure a DRM configuration using the multiplex editor. As you can see, we have multiple of these configurations prepared. In fact, there's a whole list of pre-existing configurations that they already created. And the point is now that I can switch between these pre-existing configurations at any time, either by using the calendar, an absolute calendar tool and weekly schedules, or by just manually switching to another configuration using this play button here. Good. Now the next point is, where do these service components come from? The audio, text messages, journal line, how do I configure them? And that's done in the service component editor. So in the service component editor, it's the same approach. We have a whole list of service components. These service components exist in the content server and are ready for use in any combination for the creation of on-air multiplex configurations. For each of these service components, we can now upload data, or they can automatically import data, however we've configured it. They are fully active and available, even if they are not at all times on air. To create a new service component, you just click on Add New Service Component and select the type of service component. There's journal line, SPI, service logos, slideshow, transparent file transmission down here. All of these protocols are available and can be selected. Our focus for the distance learning is now journal line. So let me show you quickly how that is done. I say add, which creates a new service component. First, I need to give it an internal name. This is just for us to be able to select this service component in our multiplex configuration. And as you saw, once I provided a valid label, the warning up here is gone. That's also one important part. You cannot make any mistakes. The content server will always check for consistency, and once it accepts the check and save of your data to be stored and put on air, you can be sure that it is a valid DRM transmission. Of course, you can misspell your label, but there cannot be any misconfiguration that would lead to an invalid on-air signal. Good. And for the service component, for every service component, I have these general parameters, and I have the content providers and sources. Content provider is the internal term for a data source. So for every service component, I need to create at least one data source. Where is this particular information for journal line coming from? And again, for this, we can provide a label, DRM news. And the important part is here, import mode. The content server server will provide a variety of import methods to connect with existing data sources. And the selection here depends on the application type. So for Journaline, we can use XML file upload or import. We want to use now for the quick demo an RSS feed. An RSS feed is a news feed that's on the internet. And let's have a look at the exact URL for the RSS feed of drm.org. So all the latest news of DRM are available on this RSS feed. The link is given down here. I'm going to make it even easier. So this is the link that we are just using, drm.org/RSS. I'm sure there is this logo somewhere on this page. It should be down here, right here. It's an orange logo. You will easily recognize it once you see it on our web page. Good. With that, we can now go back to the content server. And in the content server, you just provide this URL for the RSS feed. And finally, there's a button here, test the RSS feed, to help you make sure that the RSS URL that you provided is valid. We don't need to go through the whole process. This will take a few seconds. Oh, it's already done. And it shows that it could read the RSS feed. It could extract all the information from the RSS feed. And the content server would now use this RSS feed to create our on-air Journaline content automatically from this data source. That's it. You say check and save, and you have created a new service component. So this is the big concept that you need to understand. There's a twofold configuration process for on-air DRM configurations. First step is creating service components, the individual building blocks of audio streams and data, multimedia components like text messages and Journaline and Slideshow. And every service component has a data source, at least one. In the case of Journaline, there can be even multiple data sources simultaneously, and then the content server will combine them into a single Journaline service. From these service components, we can then create any number of individual DRM multiplex configurations for our on-air signal. So we can reuse the service components and we don't have to redefine them every single time. And the DRM multiplex editor then only focuses on the signaling, service labels, IDs, program type, and so on, and the capacity bitrate configuration that you select for this particular configuration. So much about how you configure a DRM transmission in the content server. That was a quick run through, and I hope it will help you understand then the next steps, the actual application implementation of the distance education service. You have seen how to configure the DRM content server, and you have seen the DRM multimedia player and how it immediately reflected on the receiving side what we configured in the broadcast side. And with that, I'll now hand over to Timaya to guide us through the actual configuration of our distance learning service using DRM as a combination of Journaline and audio components.
Thanks, Alex. That was really nice explanation. So with that, great foundation, I think I can easily explain how the DRM distance learning can be done as an example. So yes, DRM can enable or facilitate distance learning by combining the two components, the traditional audio with the exciting journal-line service. So before I jump into technical details, I would quickly show the user experience. So it's illustrated here. On the left, you can see the audio service. So I have the transcript there, so it's for something to be listened to. Whereas on the right, you see the journal-line service, which is a corresponding material or study material, which is available for the students to browse through when the lessons are live. Of course, Journalline provides the options of interactivity. In general, you have the phone-in question and answers for students, so you can actually host the numbers on Journalline, and students can call in for clarification. Of course, there's also quiz and solutions. So Journalline can host a quiz and solutions. I have an example later, which is also a sort of interactivity. And Journalline can provide links to online resources and also post students' comments or teachers' comments on certain solutions. So it is really interactive. So just diving one step into the Journalline user experience for distance learning, you can see it's numbered 1 to 5. So typically it could look like class 1 to class 4, and class 4 with each. So once you jump into class 4, you have the different subjects for class 4, and then the different subjects, chapters, and then the lesson, quiz, answers, so on. So it's up to the creativity of the content provider or the program department of the broadcaster, if I might say, to create such interactive content. So our aim is to actually create this kind of digital learning experience, DRM distance learning experience today. So we already, Alex already walked through the multiplex editor and service component editor, so I would skip that part for now, but of course I would use it again to explain how this can be done for digital learning. So before we get into the technical details of XML, Journalline, RSS feed, and so on, what I want to explain here is that distance learning application or any Journalline service application is an ecosystem. So it needs multiple teams coming together with a lot of planning and a lot of iterations to build such a service. So on one side, we have the content or the program team, who's responsible for sourcing different content and editing it, making it proper for the Journalline. So the content team should really understand the look and feel of Journalline service, how it would look like to the end user, and use their creativity and editing capability to make it suitable for Journalline. And we have the IT team, which sits as a core team interacting with the content team and translating those content to the Journalline format so that it can be put as an input or the service component to the content server. And we have the content server team who manages the content server, monitors it, checks for errors, all of those jobs which Alex explained a few slides ago on a regular basis. And the most important thing is that all of the team would need to do a monitoring on the service to understand what's happening, if there is any errors, some editing would be needed, and so on. And it can go under iterations before it can be broadcast. So it's like an ecosystem, and it's a project that needs multiple teams functioning together. So Alex explained about the content server. I would try to explain that in a nutshell in a block diagram. So we have the contribution side, which is essentially, in a layman's term, inputs or data sources. And you can have different kinds of audio, different kind of components. One is the audio. You can have several audio components. You have Journalline. You can have several Journalline components or a single Journalline component with multiple content providers, text messages, and there is also slideshow, etc. So that's the contribution part on the left side here. And then we have the multiplex generator, which is configured using the multiplex editor. And usually you can have multiple multiplexes, but only one is on air at a point of time, but you can use multiple multiplexes, created and defined, and then you can use it for scheduling it based upon your day of the week, weekend, or so on. That's up to the broadcaster. For example, the first multiplex here has 4 services, where the second multiplex has 3 services, and service B, for example, has audio with the associated journal line, as we saw in the jazz example, and then there is a standalone journal line here. So there is multiple possibilities, and all of these is feasible using the content server. And at the output, we have the MDI, which can feed to the transmitter. Now coming to the context of distance learning, so we can have the contribution. The audio could be the audio lectures or the radio learning, I would say, and the service component for journal line would be the equivalent of a textbook. And these can be combined as a single service, which has the radio learning audio, the lectures, and the journal line material. And this can also be combined, so DRM allows up to 4 services, so you can have another service which is regularly running, so that could be a news service, for example, and these both can be multiplexed and fed to the transmitter. So this is a block diagram representation of the content server. So now let me jump into the journal line service component. So journal line service component, Alex showed how we could add the journal line service component and how we could define the content provider. It needs at least one, but it can have multiple content providers. So I could imagine that there's a news team who's responsible for the news items, and there is the COVID-19 team who's responsible for collecting all the updates or the emergency information, sports department who's collecting the live score, and all of these data can be made available using RSS feed. For example, if there is an existing content and you have already set up an RSS feed, you can reuse it, which is straightforward and easy. And if you need to build a new feature set, just like distance learning, you could also use the journal line XML files and create a whole feature set. And all of these content providers can be added as a single service component, journal line, on the broadcast side. So on the left, it's the broadcast side, and on the receiver side, it's basically the user experience. He could see or she could see this as a journal line service with news, COVID-19 sports, menus, and then you can browse through the sub-menus and so on. So that's the service component journal line, how it can be built using different content providers, different ways of feeding the data, and how it would look like. So I would explain how the journal line XML file is used here. An RSS feed is beyond the scope of this workshop. This is already for an existing content, whereas the journal line XML is a structured way of creating a new feature set. So the data source is basically the XML files, which has predefined schema, and this is where the IT team, I could imagine, would come in and try to understand the schema and translate the content from the content team to such a journal line XML. So there are 2 options possible. One is to have a single XML file called root.xml. This is it has to be root.xml, which can have all the menus and submenus defined inside a single file. Whereas option B, you can have a single root XML file as previous, but it can reference to multiple XML files. So it's up to the the preference of the department, IT department, to come up with such solutions. And this is actually then fed as a journal line application or service component. And say the content provider is distance education, for example. And content server also provides the facility to play around with the content, indexing, layout, updation. How often do you want to update this? And say, for example, you want to transmit a chunk of chapters. You could do this overnight when there is no audio being played with high bit rate. So all of these, experiments can be done on content server with the help of the content server team, per se. And for the listener, this is how it would look like. There's a distance education, and the student could click on that and choose the chapter what he wants to get into and learn. The best part is that this is also available. The audio is live, or it is played at a particular point of time, whereas the journal line is available all the time for the user to play around, to study, as a study material. So it's really flexible. So before I jump into the live demo, I would quickly show the XML structure which I have created, and then we will also look into the fourth part, basically the multiplex editor service component, but this time concentrating on the distance learning. And finally, we would try to play back that as a live demo. Please bear with me till I switch the screens. So I have created a XML project, the journal line XML project for distance learning. So the root XML is the one which can contain all the menus and submenus, or you can also reference the other XML files. So this is how it would look like. For example, the title is journal line distance learning. It's a root XML here, and you have the item which is class 1, which is based upon the XML class 1.xml. So I've created 4 classes, for example. Let me go to class 4.xml. And then this is referencing the next level of XML files for each subject: mathematics, science, and environmental studies. And then the mathematics have lesson 1 and lesson 2. And then you have the actual content here. This is purely an example. It's structured nicely, but it's up to the IT team along with the content team to come up with the solution. So this is just purely example, a basic understanding of how journal line XML can be used to build a complete feature set. Now let us switch to the content server itself. So so first we need to create the inputs. That's basically the service components for those data. So let us start with service component editor. I'm already here, sorry. And then we add a new service component, journal line. So let me try to give some meaningful names so that it's easy to remember. I'll just call it as radio book. So it's a book which is available on radio. So I have created the XML file which can do the indexing on its own. So I would say I don't need to do any indexing from here. So it's an advanced feature. English. So content provider label, so let me call it as edu department. So it's the education department who's the content provider. It automatically creates a login. So content server provides various ways of importing the data. So RSS feed is one you can see here, but we are going to use XML. And I'm trying to, I'm going to upload the, the XML which you saw right now on the Notepad project directly to the content server. And that's this option. So now I have added the service component. Now I need to provide the data. So that's the FTP link which is created within the content server. And let me open the project which I showed you, distance schooling. I have to just copy all the XML files. This is really hands-on. course, we need to start the input of those data into the content server. Looks like it's good, so there is no error, so it's imported. So now we have defined a service component called radio book, and we have provided a particular set of content from class 1 to class 4 book. Similarly, we need also the audio component for the lecture, so let's create a new service component called audio. So service component label would be radio lesson. So again, you can provide a playlist or a single file. I will provide a single file for an exemplary to provide the data. Okay. So I have a recorded audio for chapter 1 of the math lesson. It's a slight technical glitch. I will get back to it. Okay, so the content provider label has to be unique. Maybe that was a problem. Apologies for the technical glitch. And let's import the audio file. That looks good. So what did we do right now is we created two service components. It's radio lesson, which is an audio component, which has the lessons or the audio lesson, and we have the radio book, which has the textbook material. Now we go to the multiplex editor, and we can create a new multiplex. I have an example already running here, but let's create a new one. So let me call this is an internal label, let me call it as DRM distance learning. And of course we can actually set the time zone. So let's say Europe and Switzerland. And the DRM services. So we actually add the particular audio which we just created, which is radio lesson. And then I have a predefined text message, which I didn't show you, but we have created it. And then let me also add the radio book. So this service, I can call it as radio schooling, and it has the audio component, the lesson, and the corresponding text material. And then I will add a service B, which is the same radio book. Now this is for offline, or when I say offline, when there is no audio, you could really browse the whole set of book again. So this is a standalone journal line service. Let's say the country of origin is, oops. I can do the same for this. We save it. So we have two radio services, radio schooling, and okay, let me also change the name here, whole radio book. So we have two services, radio schooling with the audio and the corresponding journal line, which is the textbook material, and the standalone journal line service, which is just the textbook material. Of course, we need to take care of the channel parameters. So let me choose this. And then I will simply auto-optimize so that we have the maximum for the audio and 10,000 bits per second for the journal line textbook material. So that's it. We have a particular multiplex using the two service components which we created quickly, and we can actually put it on air and see how it plays back. So it should go on air soon, and we should be able to see an update here. There you go. So we have the radio book and the radio schooling, and we can actually see how it looks like here. That's the distance learning, class 1, class 2, class 3, class 4, different chapters, lessons, quiz, answers, so on. So I have actually created a DRM distance learning previously with all the proper logos and so on, so that it's nice to see. I would put that on air first. It should go on air soon. Perfect. So we have the radio school with the audio program and associated journal line, which is the textbook material, or we have this radio book, which is purely journal line, that's equivalent to the textbook material. Of course, I would like to play back the audio and show how it sounds. So let me restart so that we start at the beginning of the audio. The system commands are generic commands which you can use for halting the system, rebooting, and so on. I will quickly stop and restart the transmission.
Good morning, students. Welcome to Radio School. This session is for Class 4 Mathematics. Today, we will learn about numbers in Chapter 1. Please navigate to the journal line page, Distance Learning, Class 4, Mathematics, Chapter 1, Numbers. Please open lesson on the journal line. Let us start with classification of numbers. The first set of classification is natural numbers. These are also called counting numbers, and these are the ones that you can count using your fingers. The mathematical symbol to represent natural number is a capital N. On the number line, you can represent this as 1, 2, 3, and so on. Whole numbers. These include natural numbers but also include a 0. The mathematical symbol to represent the whole numbers is a capital W. On the number line, you can represent the whole numbers starting 0, 1, 2, 3, and so on. The next set of classification is integers. The whole numbers and the respective negative values make up the whole integers. The mathematical symbol that represents integers is a capital Z. On the number line, you can represent integers with 0 in the middle. To the right of it comes 1, 2, 3, and so on. And the left has negative values, which is -1, -2, -3, and so on. Now we have a quiz on what we have learned today. Please turn to the next page on the journal line. Please try to answer on your own. The answers to this quiz are in the next page for you to verify. That's it for today. Thank you.
So that was a live demo of distance learning on a very, very small scale, I would say, as an example. I think that's it from my side as an example and how distance learning can be done. So content server sits at the heart of it, where you can configure different service components, audio, journal line, and you can combine them with the multiplex editor and see how the receiver is using the radio for such distance learning education. And the distance learning is one such example. You could also use it for public signage application. It could also be used at community places like healthcare centers or other places where you can put the information on a public sign, and all of these is possible using DRM and content server. So I will. So this is what the user experience was, and we did the whole thing, and we saw the whole live demo. I hope you were able to hear the audio as well, which also runs through the journal line pages, so the students are in sync with the lecturer or the teacher, for example. And also the book is available later on for browsing and for the answers and solutions and so on. So I'll hand over this. I'll hand over the mic to Ruxandra to continue. Thank you.
Thank you very, very much. Alex and Maya, this was a lesson on a lesson, isn't it? I was quite excited and I want to know more about the full numbers, whole numbers, and all that. I hope you could follow the way this was all set up. Maybe what Alex and Maya didn't say was that although it looked like a lot of screens and a lot of setup, once you've done it once, you will be able to add to the content and follow the steps, and it will become much more accessible and easier. So I hope we could demonstrate to you that DRM can deliver education, quite sophisticated education with text and audio, and you could enhance this with pictures, maps. I mean, imagine it's not mathematics, but another subject. So we wanted to make the point that Digital Radio Mondiale, digital radio, offers much more than audio, the up to 3 channels and 1 data. It gives access to information, education, and of course, entertainment and emergency warning. You saw how the data transmission possibilities are totally incorporated into the standard, and I know we have some questions on that, so we'll come back to the questions on the data transmission. And we also demonstrated to you how the relevant information can be given to people wherever they are. Imagine a smaller transmitter covering a particular area in a particular language, which can be set up through the content server and the journal line service. Imagine a huge or a big transmitter that can cover a huge area. Also think of the savings you have. Not only do you reach lots of people, all the people in the area, all the children maybe in the area, but you only set it up once, and that is available for everyone in that area. That is the beauty of radio and of digital radio. You could see that there is nothing that the internet can offer, almost nothing internet can offer, that this system and digital radio cannot offer to the pupils. Of course, internet has an ease of access, but imagine that the benefit of having this information without internet or even electricity is immense as well. You also saw how the information can be, the lessons can be accessed separately afterwards, so the radio becomes a teaching tool, your book, your manual. So radio is not just a radio. Very often we assume radio is just pop music or music, but it becomes your companion and your book on the shelf. And I will finally make the point that in the end, radio is the final integrator, because you can get any information from anywhere. RSS feeds, audio you create yourself, integrate it all through journal line content server and deliver it to the people. So you can provide education, information, and always during a crisis like the pandemic crisis now, but otherwise as well. I think once people learn to use this tool in this way, they will get something that they will want to hang on to. So in other words, DRM for education is not just for crisis. Maybe it can become another way, permanent way of delivering education. Hope we have made the case. So let's go on to the next slide, because this was my conclusion. So can we go to that and just say that more on the technicalities? Maybe some of you thought it was a lot of technical detail, but this handbook is available. It doesn't need to go to the content server. You just need to go to the drm.org site, and you will find the latest version. If you remember, in April, those who participated, we were announcing a revised version of the handbook. Well, it's happened, and it is on the website. Please go and check it. The next slide, please. And as ever, you can follow us on the website through our newsletters. By the way, a newsletter with a summary of this webinar will appear next week, and you can write to us at projectoffice@drm.org. And I want to remind you that we are always open to questions. So if we go to the next slide, we can always try to reply to your questions. And because we have a couple of minutes, I would like to pick up some of the questions we got, which I wasn't able to answer myself. And it is, I see at least two questions which are linked to the way of delivering the content to the transmitter. So we talked a lot about the content server, which is in the studio, hopefully better than at the transmission site. But what happens? How can we make the circle from the knowledge, as it were, to the transmitter, to the student? If the transmitter, says Yusuf Ansori, is located in an isolated area, like in mountain slope, for example, and internet cannot reach, or if it can reach the transmitter, the connection is very slow. How big is the bandwidth, and what solutions do we have? Can I ask you, Alex or Timaya, to give us an answer to this question, which is, I find, probably quite describing quite a common occurrence in the Asia Pacific region.
Right. Well, if the transmitter is very remote, there must be some connection to the transmitter. Otherwise, there is nothing to transmit. At the moment, I assume it's a dedicated audio feed, audio line, or a satellite downlink, or something like this. Once you migrate over to DRM transmission, that can become a rather low bitrate NDI IP stream. So it can use any of the distribution mechanisms available for IP network connectivity, whether it's public internet, whether it's microwave links, it's satellite downlink, and it can save money because the bandwidth required is similar to what we are broadcasting on air instead of a full bandwidth audio channel. And that includes the full DRM multiplex information already with all the different audio services, multimedia applications, and so on. For a on-air transmission capability in medium wave of, let's say, typically single channel 20 to 30 kilobits per second, a 64 kilobit per second connectivity should be plenty. Of course, if you are working from offline content only, if you visit that transmitter once a week and upload new audio files to be played out, you can do the same with the journal-line content as well.
Thank you, Alex. And there is a similar question from Rajesh Kuryan, who asks whether slides can be sent from remote machine via web interface. Probably the answer is yes, but
yes.
Let me let me make absolutely sure for everyone and for Rajesh.
Yeah. So what we have shown, what Maya has shown us today, was obviously the manual upload of information. In a production scenario, the whole connectivity, similar to what we saw with the RSS feeds, which are updated automatically by the kernel server every few minutes. That whole connectivity with the data sources, with the content providers is automated. There's nobody physically or manually copying around files and triggering the import. That's the manual process, but for production systems, everything is automated. And the content server has these interfaces and tools included.
And our honorary member, Mr. Pal, makes a very good point that this system, which was just explained, is very useful, especially for lectures by experts who can't go to every school. And that's a very good point. It's not just teachers, but imagine you have a great expert and they deliver a fantastic lecture. Unless this expert, I was going to say he, but why not she, he or she goes to each individual place, which is not possible. This is the way to do it. It's a bit like our webinar. We would like to go to all your places, but we can't. But we have had over 160 participants being able to take in this webinar. We also have a question from Mufag Al-Shamari, and it's a trickier question, so we don't avoid these. It's which DRM receiver is recommended for education applications? Do we have a preferred receiver, or is it, I mean, I have the answer, but again, I will ask you, Alex, or Maya to give the answer. There isn't a specific brand that is linked to these education capabilities or capability of DRM, is there?
Right, exactly. And this also matches several of the questions I received, which we will look at in a moment. What is the best tool? Should it be a tablet integrated receiver? Whatever should it be? And as you might remember, some of you who were lucky enough to visit BES show and expo in Delhi earlier this year, there a company, in this case it was a Starwaves receiver, I believe, they announced to have a radio with a hotspot feature built in, meaning that you have a DRM receiver centrally in a village or in a household, and then anybody around that using any tablet, mobile phone, anything that has a web browser can connect through a local Wi-Fi hotspot to this DRM receiver and access the information on a large screen. I think that's one of the most realistic options. Then, of course, if you have more advanced receivers with a larger screen, ideally touchscreen, they would be perfectly suitable as well. Do you have more questions, Alexandra? Because I also have quite a bunch
Yes.
to look at.
Yes. The last one from me, which is very technical, is from Mr. MS Duhan. Can configuration of DRM transmitter be carried out differently for different channels, like PLP in DTT? So here, I think this question is above my head, so I pass it on. I pass the mic back to you.
Right. So in DRM, each transmission is a very small multiplex. It is a maximum of 3 audio services plus data. And therefore, we don't need that much flexibility. What you do is you provide the basic configuration, the QM mode and the mode, robustness mode A, B, C, D, and E. You select that for the whole DRM transmission, but then you can select up to 2 different protection levels for every audio stream or packet mode stream. And then you can, for every audio stream and packet mode stream, you can decide if that particular stream should be better protected or should use a higher capacity. On top of that, for the packet mode transmission specifically, there is an added layer of error protection against dropouts on the receiver side called the enhanced packet mode that uses forward error correction. That can be enabled and can be configured to various protection levels.
Good, Alex. Why don't you pick one or two before we wrap up? I have tried to reply in writing to some of our attendees who have asked questions, and yes, please send us the questions and we'll reply to them in writing personally, and we'll choose the most interesting, not necessarily the easiest, and post them every week, Monday or Tuesday, on our website.
Good. One question was about content. Is it possible to use Arabic fonts in journaline? And the answer clearly is yes. Of course, we have to make sure that the receivers sold in a specific region support those selected character sets as well. And this is what we have the new profiles for. That applies to Arabic, but also Chinese, some Indian languages, and so on. So yeah, definitely it's a given. Another question was about the addition of visual components, in this case mathematical calculations and formulas, but also in future for other subjects, diagrams and graphics that are non-photos, non-JPEG or PNG technically seen. And for that we are now working on adding SVG support to journaline, so that you can have very small size but still fully scalable and very detailed vector graphics, including then mathematical formulas and stuff like that. And by the way, if you want to contribute to the technical foundation of this education service, the journaline technical specification, there is work going on in the DRM and DME consortia, and you're always welcome to contribute and become a DRM member to join in with this effort and give your expertise and also your requirements. The synchronization of the journaline content, as Timaya explained, it's a textbook that is delivered and accessible on the receiver side. And as you could see in the example that was shown in the demonstration, the easiest way of synchronizing once we have the live session is by the announcer pointing out the appropriate chapter and topic in the journaline service, similar as they would do in a textbook format. How much content for journaline is stored in a receiver, and is it always accessible, and how long does it take to switch between pages? The way journaline is structured and created and standardized is that it doesn't need an overall directory to be transmitted to the receiver. Every menu page, every text page is independently transmitted and can be presented independently. All this content in a proper receiver is then cached, and once the content is cached, so once the first cycle of data was received in the receiver, from that point on, all the receiver does is look for updated content, modified content, and then updates those individual pages received in the cache. destination of the journal line service is from that local receiver cache. So once it is received, you have it available even when you're offline, and you can navigate immediately and instantly between all those pages. You don't need to wait for on-air repetitions of the content. The amount of content that a journal line service can comprise is up to 65,000 pages of content, and every page can carry up to 4 kilobytes of data depending on the script you're using. That's a loosely written A4 page or letter page, roughly. So you can split up your content as you require it and give a meaningful and sensible menu structure that helps the user on the receiver set to quickly access the information they are currently seeking and interested in. Can journal line embed images? Yes, I mentioned that. It does embed images for JPEG and PNG, and now also for SVG, scalable vector graphics for even smaller size and full scalability on the receiver side. What else? DRM receivers. Yes, I mentioned the hotspot feature, so that you can use any tablet or any mobile device available, even a modern TV screen technically, that can connect to this local DRM hotspot receiver through Wi-Fi. And then the built-in web browser is responsible for rendering the fonts, which means that Arabic and any other special scripts that, I mean, from my perspective, special scripts that are required, if the browser can properly handle them, already fully supported on the transmission side. For the transmission of content, what is the impact of the configuration on your DRM signal? As a general recommendation for content such as journal line and also the either embedded or internally linked images, my recommendation is always enable the enhanced packet mode. That's the way. If it requires some capacity, there's a certain penalty on capacity, like 10% overhead over your transmitted content, but it provides extra for error correction. So if the receiver has individual reception errors, they do not mean that the whole image needs to be repeated with the next iteration and broadcast, but instead the image can just be recovered from that first iteration of transmission. So it increases the reception robustness. The synchronization or overnight reception of content, that is something that is probably useful for real full documents that you want to distribute throughout the country for offline use. For journal line itself, it's not required because journal line is so small bitrate that even on a medium wave transmission or shortwave transmission, it can be sent out along the audio signals and doesn't really affect the audio quality in any form and still have sufficient bandwidth to be received in a proper time frame. Mathematical equations, I mentioned, yes, SVG is being added. There was a question about receiving solutions. The photographer multimedia player that you saw is, as such, is not available publicly, but we are now in discussion with a Korean company to make it available for Android, and on the receiver side, it does already support various SDR front ends, including RTL sticks, so that's already part of it. That's the amount of questions from my side. Anyone else?
Yeah, thank you, Alex and Rukchandra. Yeah, we have a lot of questions. The questions are flooding in. I believe we have a short time, and I believe Rukchandra already said that she will provide those things in writing later time. So how about Rukchandra? Do you intend to provide answers in writing, because there are a lot of questions coming in here?
Yeah, after the April webinars, which were most successful, and thank you once again to ABU and ASBU, we received over 90 questions. We were struggling, I must say, not because of the difficulty of the questions. Some of them were extremely interesting and difficult as well, but it was just the whole writing and checking and all that. So by all means, send us your questions in writing and we will try to answer them. But don't expect an answer like in the next 24 hours. And please limit your questions to one or two. Last time we got like 6 or 8 questions from one single person. And without being rude, we want to be very helpful to everyone. I think we should limit it to one question per person or two maximum. But please write to us at projectoffice@drm.org anytime. And if you want to participate in this particular project of DRM for education, join the consortium. You can do it individually as a company. Join our technical committee and join the conversation. I mean, I think this webinar has just shown a few things. It is the time to go in depth, learn, and we can learn with you and develop all this. So I know we are running out of time, and I would like to draw a close to this. Yes, we reply to questions, send questions. We will pick up questions and put them on the website, so your name will be there if your question is picked. And let's continue the conversation. It's been absolutely fantastic, and I cannot thank enough Shri, Nadim, the whole staff of ABU, and also ASBU, and especially Alex and Timaya. Thank you.
And one last comment from my side, if I may. What you saw today is a tool set, is the capability that DRM can do and what tools are available on DRM digital radio. What now is required is that you as a broadcaster build up the expertise, how to use these tools, and on the other side also include the content department, because at the end of the day, it's down to the creativity and the imagination of what content can be provided and what is the most relevant content for your listeners and where you can source this content. That really distinguishes a fantastic, phenomenal digital radio service from an off-the-shelf audio-only analog equivalent. Thank you so much, everybody.
Thank you, Alex. Thank you, Alex. Thank you, Rukshandra. Yes, surely we will pass this question to you for writing, answers in writing. And then, dear colleagues, dear attendees, we will come back with the slides today and the answers from the DRM consortium in due time. And okay, at the end of the session, let me once again thank Rukshandra, Alexander and Timaya for excellent presentation and live demonstration here, really. And before we leave, let me announce that we have tomorrow we have one more great webinar on SDR considerations in production and broadcast environment. So that will be at 2 p.m. here time, just 2 hours before today's time. So please tune in for tomorrow. And of course, we will be giving you some more circular for upcoming weeks as well. We have some webinars in pipeline. So with that, let me thank you again. Thank you for your wonderful participation, and your DRM Consortium colleagues. Thank you very much for all the presentation today. So with that, let me close today's session, and of course we'd like to see you again tomorrow and next week, next days to come. Thank you very much. Bye. Let me end this webinar now.